Oh, different letter. Oh yeah, I won't use S. Okay, sorry. So we've already started recording. Find angles between two equations. We're going to change this parameter, specifically between two vector equations. So we've done finding angles between vectors before, but not when they're in a vector equation form that we have here. Our first vector here is going through the point of 13, 28, and has a directional vector of 1, 3 with the parameter t. And our second one goes through the point 16 and 10. I'm going to change the parameter so we don't get confused. We'll call it P for parameter. And directional vector 95 and negative 8. What a direction. Okay, so we know from before that we've learned a few formulas that will help us find angles. One of the formulas you may recall is if we find the dot product between two values is equal to the magnitude of a vector times the magnitude of the other one times cos theta. And essentially, theta would be the angle between the two vectors that we're looking for. So what we're going to do is we're going to solve the rest of this information with vector r and s, and we're going to apply it to our dot product and rearrange this equation to solve for theta. Now, these vectors are going through specific points, but the points aren't what's most important to us. What's most important is our directional vectors, because our directional vectors at the origin will form the exact same angle. Okay, so what it is at the origin, they'll form the exact same angle that these other two vectors, when they eventually meet in space, will form. And that wasn't the greatest example. Kind of like that. Similar. That looks close. Okay, so really the only thing we have to focus on is our directional vectors, and we'll work with that information. Okay, so our first directional vector is 1 and 3, so we'll call that vector A for our dot product. And our second one is 95 and negative 8. We'll call that B for our second one. Okay. We're going to rearrange this cos formula so that it now says cos theta is equal to the dot product of A and B over the magnitude of A times the magnitude of B. Okay. Now the dot product, if you guys recall, to find the dot product of two vectors, we're going to multiply the x values by each other, the y values by each other, and add them together. So essentially, we'll do this as two pieces. A dot B is equal to 1 and 3. That's vector A, I believe, right? Scroll up, yeah. Dot 95 and negative 8. So there's our directional vector B. We take our x values. Is that right? We're okay? Okay. So 1 and 95, and then the other one become subtract 24, which should give us 71. Is that right? Okay, so our dot product of our two vectors should be 71. And the magnitude, if you guys recall, if we find the dot product of itself, it becomes the magnitude squared, which essentially gives us the formula of the magnitude of A is equal to x squared plus y squared square rooted, right? That's just a rearranged one from what we had before. So we take, for magnitude of A in this case, 1 and 3. So we take 1 squared plus 3 squared, and we're going to find the root of that. We have 1 plus 9, which is going to give us root 10 as the magnitude of A. And the magnitude of B, which I'm going to need your help for, is 95 squared plus negative 8 squared. Negative 8 squared will give us our 64. What will 95 be? I have a calculator too.
9,025.
Let's see, 9,025? Great. Did that in your head. Amazing. So we'll add those together. We're going to get the root of 9,091. 89. Who rolls off? Okay. 89. Okay, good. So we have our magnitudes. So root 10 and 9,089. Okay, so we'll take those values. I'm going to skip over a bunch of stuff down to the bottom here. So sorry about that. I'll draw an arrow to come down. I didn't leave myself a lot of room. Which means cos theta is equal to, or actually, we can do this all in one step. Theta will be the inverse of that. So cos inverse of 71 divided by root 10 times root 9,089. Anyone know what that theta is in that case? What is it? 76.4. Excellent. 76.4 degrees. So the angle between our two vectors when they're in vector equations is 76.4. Very similar to what we've done before. We just had to take out the important piece of information, which is essentially the two directional vectors. Make sure we know what is important. And we've done this process a few times, finding angles between two vectors.